This lesson is called Further Details on the Composition of the Earth. This lesson can be done all together, or you can stop at different points. Remember when we talked about how the Earth was formed? We also talked about everything inside the Earth settling according to its weight. The heaviest things went to the bottom, or nearer to the center of the Earth, and that part was called the barosphere. Remember that? On top of the barosphere settled the lighter part, the lithosphere, and the part that we live on top of. Well, inside of the barosphere, things also settled according to their weights. The heaviest went to the center of the Earth, and the lighter part floated on top. And still, lighter parts settled on top of that. The heaviest part that went to the center is called the core of the Earth. The part surrounding the core is called the mantle. And on top of that, the still lighter part is called the crust of the Earth. It's also called the lithosphere. That's the part that we live on. Now, as we know, the crust, the part that we live on, is quite solid. The part underneath it, the mantle, is not quite as solid. In fact, that we say that is plastic. And we're going to learn about plastic on another day. The core of the Earth, I wonder what it's like. Well, scientists don't all agree because no one has ever gone to the core of the Earth, so they can't really check it out for sure. Some say that it is a liquid, and it has always been liquid. Others say that it is semi-liquid, and still others say that it's solid. One thing that they all agree on is that the further one goes into the Earth, the hotter it gets. We assume that the core is the hottest. Well, what about the crust, the part that we live on? Well, there's a division according to weight in the crust as well. The crust is made up of predominantly two kinds of rock. One is granite, which is the lighter of the two rocks. Granite is composed of little tiny grains of crystal. The other kind of rock is called basalt. Basalt is the heavier of the two rocks. So, remember when we were talking about how the Earth was forming, and we talked about at that time when it was very, very hot and everything was in a gaseous or liquid state. Well, at that time, the granite and the basalt were liquids. The lighter rock, the granite, floated on top of the basalt like this. The granite floated in the basalt, and as the Earth cooled, the granite got trapped just like a ship can get trapped in a frozen sea. You can see that most of this cube is sticking out under the water, just like the basalt and the granite. Now we can also see that the granite and the basalt, and how in certain places where the granite was trapped, the top part was sticking out. This is where we have the continents on the Earth, and in the hollows in between is where we have oceans. Okay, well, together, the blocks of granite and basalt form the crust of the Earth. This is a stopping point. So together, the blocks of the granite and basalt form the crust of the Earth. However, the crust is not one continuous solid shell covering the mantle. We can think of it more like cracked shells because it is broken into several big slabs. These pieces are called plates. These plates float on the mantle, drifting about, sometimes rubbing against each other and sometimes colliding with each other. Most of the time, we are not even aware of these movements of the Earth's crust. We just see the results. Wow. Let's take a look at this. So, if you think about a river, and if we've done the river experiment, then you might know more about it. But the Mississippi River washes down about 406 million tons of sediment in 1 year. So it's all dirt that gets washed down, right? So it's washed down by the Mississippi River, and in just 1 year, it builds into a column with a base of 1 square mile to the height of 241 feet. Can you imagine how big that would be? And that's only in 1 year. Well, if you could imagine all of the weight that's washed down and it's dumped into the sea and the land in that area gets pushed down. Maybe if I turn it this way, we can see it better. So it gets pushed down like that. Now, if the weight is removed, right, the land goes back up just like you see here, right? So as one place goes down, another place gets pushed up. And if I put it over here, it gets pushed up over here. And if I put it here, it gets pushed up over there. Wow. As the rivers wash away the earth in certain places, the weight is lessened in those areas and the land goes up. So wherever sediment is deposited, the weight is increased and the earth goes down. In one place, it'll be rising up, and in another place, it'll be sinking down. So we can see that right here. Okay, so we have our land pushing down here, and it's rising up in other places, right? So the earth can rise up because of all that washing away. And where it's deposited, the earth goes down because the weight is increased. And this is possible on the surface of the earth because that mantle is plastic, and so it can bend. This is called isostatic balance. There is a constant balance on the earth. If there is a weight in one place, there's a building up of another. I have something else I want to show you. So the crust of the earth is broken into plates which move about. And as the plates move about, sometimes they rub against each other. So I have 2 plates, and sometimes they push against each other, and it builds up like that. And slowly, over many years, the land begins to build up and we get a fold. Scientists think that this is how many of our mountain ranges on Earth have been formed. Now, there's something else that happens as well. Scientists have found that in some parts of the earth, there are ridges that mark off the margins of the plates. Along the ridges are cracks where molten rock can push up against one of these cracks. When it does that, it spreads out in 2 directions, forming new crust. The crust spreads away from the ridges and the ocean bases and are widened in this way. This generally happens under the ocean basins, and sometimes the edge of one plate gets sucked under the edge of another. You can see that it's kind of like this. So we have our 2 plates, and one just goes right on top of the other. Okay? And when that happens, the edge of the plate that goes under gets folded and crushed under the plate that's on top of it. The rock sinks, and you can imagine the friction that that causes. And as a result of this, we get earthquakes. The part of the seafloor that gets drawn back into the mantle gradually melts under the heat and pressure. Now, occasionally, as this molten rock comes across the water, it turns that water into steam and gas. And this creates a lot of pressure that has to be released inside of the earth. Generally, it is released along the edges of the plates because that's where the crust is thinner. Even though the crust is a solid, it can only take too much pressure. If that pressure is too great, it breaks. And we have seen that idea before, right? If you break something with a hammer. Now, at a certain point, when that pressure is too much and has to be released, the crust cracks. And the molten rock shoots out, and we get a volcano. So now, for follow-up, you can do a study of volcanoes. You can learn about plate tectonics. You can make a nomenclature booklet of all the parts of a volcano. You could learn about different kinds of rocks. You could study the core and how hot the temperatures get. So all kinds of things that you can do to follow up.